hydrogen burns to nothing but water. It could power steel mills, ships and trucks with zero carbon. So why isn't the world running on it? Because almost all the hydrogen we make today comes straight from fossil fuels, and the clean version is still too expensive. This is the real unglamorous story of clean fuel. Hydrogen gets color-coded by how it's made. About 95% of today's hydrogen is greys, stripped from natural gas in a process that pumps out CO2. Green hydrogen is made by using renewable electricity to split water into hydrogen and oxygen with no carbon at all. Green is the dream. The problem is it costs far more because splitting water takes a lot of energy. Water is stable, that's why it's everywhere. Forcing it into hydrogen and oxygen means pumping in serious energy, either as electricity or as heat, often very high heat. If that energy comes from renewables, great. If it comes from a power grid running on gas, you haven't gained much. The whole game is making the splitting cheaper and cleaner. Here's a clever angle researchers are chasing. Factories, steel, cement, chemicals throw away enormous amounts of heat. What if a catalyst could split water at low enough temperatures to run on that waste heat? In 2026, University of Birmingham researchers reported a barium, niobium, calcium, iron, perovskite catalyst that splits water in the 150 to 500 degrees Celsius range versus the 700 to 100,000 degrees conventional systems need. In principle, the free waste heat from a steel mill becomes clean fuel. And here's the honesty this topic demands. A promising catalyst in a lab is not an industrial process. Scaling chemistry to a working plant, durable, cheap, safe at millions of tons, is the hardest, slowest, most expensive part of energy science. The history of miracle catalysts is mostly a history of ones that never left the bench. This could be different. Most aren't. Suppose we make hydrogen cheaply tomorrow. We still have to store and ship it, and hydrogen is the smallest, lightest molecule there is. It carries little energy per unit of volume, leaks through materials that hold other gases, and must be compressed to extreme pressures or chilled to nearly absolute zero. The fuel is clean, the logistics are brutal. Because of all this, hydrogen probably won't power your car. Batteries already won that race. Its real future is in the hard-to-electrify giants, steelmaking, fertilizer, shipping, long-haul industry. That's where clean hydrogen, if we can make it cheap, would matter most. Hydrogen isn't held back by physics we don't understand. It's held back by cost, scale, and logistics. Every cheaper catalyst, every clever use of waste heat chips at that wall. Clean fuel won't arrive in a single breakthrough. It'll arrive one boring engineering win at a time. Science. Untold, where the future is built, not announced.